Hello, welcome to another feed scroll generator tutorial for Autodesk Inventor. This is the app that allows you to automatically create beautifully smooth feed screw geometry directly inside of Inventor. This is tutorial number 8. This time we're looking at how you can create a double threaded shaft. So this isn't two shafts side by side controlling the same set of bottles. This is a single shaft with multiple threads cut into it, so there's multiple routes for the bottles to go. Let me switch to a different view here and you'll see what I mean. If I change to wireframe, and if we follow the route for this bottle for instance, you can see that it's actually skipping over the other bottles. So we've actually got two paths for the bottles to follow, and if we switch back to a shaded with edges view, you can see that those two threads are cut here. Here's the first thread starting from here, here's the second thread starting from here. Okay, both on the same shaft. So we're going to create this shaft now for this tutorial, and we're going to exit out of this simulation of this finished example so that we don't cheat, and we're going to create a new empty part file to start with. So I'll hit File New here, New Part, and hit the Generate button on the app. This will create me a new starter shaft with the default settings. We're going to work our way through mostly from top to bottom here to design our first thread for the shaft, and then we'll add the second thread on afterwards. And maybe I can say here, if you are wanting to skip through to the important bits specifically for creating double threaded shafts, then the only important bits you need to know are your bottle pitch has got to be at least twice the diameter of the bottle, because as we said before, you've got two paths of the bottle for the bottles which are sitting side by side, so make sure you do that when creating the first thread. And when you've created the first thread, you can come back into the app form here, you can turn on the cut second thread switch there and set the rotate in degrees field to be 180 degrees, which will give you double threads but on opposite sides of the shaft, diametrically opposed to each other. And then you can make other changes to the bottle pitch, so on and so forth, or you can just hit generate again and it will cut the second thread for you. So that's the top level steps we're going to do, and let's jump into it now. So we have to cut the first thread first. We haven't got a second thread on this part already, so we can't switch this option on. Shaft rotation we can toggle here. Let's just leave it as a right-handed shaft. Length of this shaft, let's make it 750 millimeters, and the diameter of the shaft, let's make that 90. Now the bottle pitch is going to be dependent on the size of the bottle, of course. Let's assume that the bottles are touching at the start, but first we need to know what size the bottle is. So let's head down here to the bottle sketch. Of course we can import a 3D bottle shape as you've seen in the other tutorials. We're just going to keep this with a simple example of a circular bottle. Focus on the double threaded shaft aspect here. I'm going to double click there, just make this a 43mm bottle. Hit finish sketch up the top here, and the form reloads. Now bottle pitch, when you're making a double threaded shaft, you need the bottle pitch at all times along the shaft to be at least twice the size of the bottle, because you have two alternating paths for the bottles as we saw a moment ago. So my pitch at the start has got to be at least twice 43/86 in order for the bottles to not be clashing. So we're going to say that the bottles are touching at the start, or effectively touching, and let's say that we want a gap of say 40mm between the bottles at the end of the shaft. So I need to do the end pitch is 86 plus 40, which is going to be 126. And then as usual we've got our lead in and lead out values. That's how long we want the pitch to stay 86mm at the start. Normally we use a sort of 1 revolution there. We can really make that whatever we want, so in this case I'll just make it slightly more than 1 revolution. And what distance from the end do we want the pitch to remain? 126mm, so let's make that 40mm more than the end pitch. So we've got more than 1 revolution of pitch at 126mm at the end. So moving on further down, we need to move the bottles outwards a bit. They're too deep in the shaft at the moment, so let's maybe set that to 95. It's probably still slightly too much embedded. There, something like that would be typical, I guess. Okay, and for this simple example, we're going to not have variable distance of the bottle from the center. We're not going to have bottle rotation, and we're not going to have bottle oversize initially, at least. We'll create a single face shaft. It's nice and simple, and we don't need a lot of loft rails or profiles because, again, it's a simple layout. And we can just hit go here in order to start creating this shaft. So I'll hit this button. The app's going to get crunching the numbers, and it's going to give me my progress up here. As mentioned before, we can cancel the generation of the shaft if I realize I've made a mistake here, and that will take me straight back to the form where I can correct my mistake and hit build again. Okay, so I'll speed the video up now. Okay, so that shaft's created in exactly 2 minutes actually, and we'll say that we do want to continue with another operation. So here's where version 5 of the app is very handy. If I say yes here, we just, as I mentioned before, have the option to simply say we want to cut a second thread on this shaft and retain the existing thread that we just cut just now. So I'm going to turn on cut second thread, and then we get a preview here. The preview shows the first thread that we've just cut because we have the option of moving the first thread around in order to not place the second thread directly on top of it. Let me show you what I mean. At the moment, we can rotate the first thread by any amount of degrees that we want to. So if I put in here 180 and hit enter, you see that the original thread is going to be rotated 180 degrees before we cut the new thread. Doesn't have to be 180. I could do this, and that would kind of overlay the two bottles. They'd be overlapping, which wouldn't really make sense, but you get the idea. I could leave that as 0. Then if I hit generate, I'll actually be cutting the second thread exactly on top of the first thread, which will work, but of course won't make much of a difference to the design. If I leave the bottle in the same position, don't rotate it, and change the shape of the bottle here, for instance if I made it a rectangular or elliptical bottle, what I'd actually be doing there is cutting a rectangular or elliptical path on top of the circular path. This would enable me to create a sort of interesting compound bottle shape by cutting the two threads on top of each other. That's not what this example is about though. What we're doing in this case is we're just going to effectively rotate the shaft by 180 degrees so that we cut the new thread, the second thread, exactly on the opposite side to the original thread. Now there are other options for how we want to move the second thread relative to the first thread. You can actually offset it rather than rotating it here as well, but check out the next tutorial, number 9, for an example of where that becomes useful in bottle grouping. In this case, we're rotating it by 180 degrees, and we could then make some changes to the bottle pitch independent of the first thread. So that would mean that the second thread on our shaft will have different characteristics to the first thread. We can, as I mentioned, change the bottle shape. That means your double-threaded shaft will be receiving a bottle of one shape on one thread and another shape on the next thread, which is interesting. It's not what we need to do in this scenario. So I'm just simply going to hit generate again. The preview remains so that you can see exactly what you're going to get as a finished result, and it's going to go cut the second thread now, so I'll speed the video up. Okay, we've got the finished result in just over 2 minutes in this case. I'll say yes again. I do want to continue with another operation because I actually want to see all the bottles moving for both of the threads as part of a simulation. So I'm just going to save this design, and let's run the simulation. Okay, so the simulation should show the bottles for both threads. If you've got 3 threads on a shaft, it will show bottles for all 3 threads as well. I'll show you how this is done in a moment. And I can drag the slider along, and you can see that that is a fully functional double threaded shaft there. Okay, so let's head back to the actual shaft itself by finishing the simulation here. And I'll show you how the app knows to simulate the 2 sets of bottles there rather than just the one of the last thread that we cut. If I escape out of the app here, you don't need to worry about this as a user of the app, but what the app actually does is it saves the sketched routes of the bottles in saved sketches here. So you can see we've got 2 saved routes for the bottle at the moment, 1 for each thread on the shaft. If we were to cut a third thread on the shaft, we would have saved sketches number 3 as well. Okay, that's the end of the tutorial. Thanks very much for watching as always, and check out the other ones if you have the time. Take care.